Hello, Robo Gym. Hey guys, I hope you're hanging in there with this quarantine deal. Hey, we're all sorry for this, and we're doing the best we can. So I hope you're all doing well, and you're having a good time, and you're spending your time wisely, and having some fun. So the other day, I decided to have some fun, engineering fun, where I threw up a few pictures on Slack, and I asked you guys to guess what it was. And no, James, it wasn't a, what was it? What was it, the power plant? No, not a power plant, with the arms plant? Whatever. No, I'm not really into arms, but I am into machines. I like machines, and what you see right there is a fine machine. It's really it's a great machine, and I'm glad it was brought into my life by Bob. A little bit of quick backstory about this simple machine, and hang in there, Louie. We're going to get to the fun stuff, man. There's some stuff in this machine you're going to like. But anyway, I think it was Bob's mother-in-law. Might have been his mother. I think it was his mother-in-law. They were clearing out her house, and she was a sewer. And she had gotten this machine and used it. And it turned out that this machine is an 1802 Sears Kenmore, top of the line sewing machine. And it happens to be in the sewing world, it's quite desired. It's a very good, known to be extremely reliable, as well as it's actually computerized. That's right, Raytheon, man. There's a computer in this 1968 sewing machine. You might not think so, desktop computers were just being conceptualized, but Sears put a computer in their sewing machine. I'm going to show that to you. And actually this all went on when we were back in the wood shop. Yeah, we were all building a robot back in the good old days, enjoying each other's company and having a great time, and I miss that, you guys. So I went out and grabbed this machine, put it in my garage. And now that I have a little extra time on my hand, I said, let's go check that bad cat out. Let's see what it's at. And when I looked at it, I explained to Madalena, my wife, that I think this machine could do some stuff that you need to be done. If you don't know, Madalena's a pattern maker and sample maker, so she's a professional garment engineer, is what I would call her. And so she has a great love for great sewing machines, and this is one of them. So 1968, and it's actually you can see it's in fine shape. And this machine here can do up to 36 stitches. Okay, lots of great things. And I'm going to show that to you in a minute. But let's take a run over to 2020. Okay, what you got there is a Benina. It's an Italian-made machine, fully computerized, probably does 100, 250 stitches, I don't know. I can hook up my computer to it, I can program it to stitch a pattern, I could make a smiley face with it. This baby is state-of-the-art, but, it's got its limitations. So there are some things that this 68 machine can do that this guy can't. Not only that, is this machine, I'm going to say that Sears machine, if I had to guess, I haven't looked it up, I'm going to say if it was $40, was a lot of money, $3,000 to $4,000, guys. That's what you're going to pay for something like that. Okay? But that's not what we're here to talk about. We're talking about this bad boy right here. So like I said, I threw out some pictures of what was there, and let's give a big shout out to Lexi, one of our future promising engineers. She immediately saw that it was a sewing machine. She second guessed herself, but Lexi's going to stop that. She's going to start going with her first guesses, because that was right, and I owe her a couple of slices of pizza. Cheeseless, of course. Okay, so let's go through the workings of this 1968 sewing machine. I think you're going to be pretty impressed in this small package. I don't know if I have a ruler here. Here we have a tape measure. So in this little package, we know how big our robot is, right? So in this package, we're 16 inches by about 12 inches by about 7 inches deep. Okay? In this little package, let's show everything that's going on in here. Okay? Remember, we said all metal construction. in here. This is the door to put in our floppy disc Raytheon. Here are all our floppies. We put it into the computer here. That's right. This 1968 machine has a computer. Let's take the top cover off. The top cover is all metal. These are all metal die castings. They don't make things like this anymore. It's too bad because these are beautiful pieces of metal that last a long time, 52 years. And still here, ready to go. So with that, let's go through the inside of the machine. I keep losing that 2x4 that I'm using. How far can it go? Alright, there it is. So, you just need this here to prop the machine up so I can talk to the inside. Let's make sure you got a good view of that. Yeah, that's not bad. Alright, let's get a little better light on that. Yeah, a little better. Okay, so what we got going on in here. So way over here on the right side we have the flywheel. The flywheel is connected by a belt. See that black line there that you can see? That's a belt that goes down to the motor at the bottom of the machine. The motor comes up, it goes through an idler pulley. Right? That idler pulley actually acts as a clutch, so if I overload this, the belt will spin here and not on the flywheel. So let's rotate that around. So this gold piece you see coming up here, that is the crankshaft. This crankshaft takes the rotary motion of the main drive shaft of the machine. This rotary motion turns it into an up and down motion and sends that motion to the bottom of the machine. So there's more we can do. If you notice, the machine's in a U shape, right? We do a mechanical up here, and we do mechanical down here. So we're transferring motion from here down to through the main column of the machine over here. Right? So the first thing we do is we change that rotary motion to an up and down motion. We send it to the bottom of the machine. Okay, let's keep going on the shaft. What you see right there is a cam. For those of you who don't know, is a cam is basically a round or an oblong shape, okay, that spins around a shaft, and because it's got a bump on it, it makes something else move the length of that bump, right? If the bump is 4 millimeters high, it's going to move something up and down 4 millimeters. And that's what it's doing. You can see this fork here. Okay, see that fork going back and forth? Okay, that's riding on that cam. And that's taking the rotary motion, making it a side-to-side motion, and believe it or not, it sends it down to the bottom of the machine and makes it an up and down motion again. That motion is transferred all the way across the bottom of the machine to take the dog foot of the machine. The dog foot is what moves the fabric while you're sew, and it's taking that dog foot and it's making it go up and down. Okay, so as this rotates, this cam is making a little foot with teeth on it go up and down over here. Let's keep going. And I'm going to tell you that this crankshaft, this does many things in the bottom, but one of the things it does is it runs another cam in the bottom of the machine that makes that dog foot go forward and aft. So you combine that up and down motion with the forward and aft, and now you got a foot at the bottom moving the fabric, going up and down, grabbing the fabric, pulling it while the needle's up, needle comes down, sews a stitch, it rotates around, moves the fabric again. And that keeps going while this shaft is spinning, right? This is turned by a motor. It just goes spinning at whatever. I'm going to say it's about 300-400 RPMs, and we make stitches with a sewing machine. So let's keep going. So this shaft continues, right? This shaft continues. Over here is a worm drive that drives this at a right angle. Okay, it's like a rack and pinion is kind of what it's going on there, and it turns this disc here. This is the computer of the machine. This is a 1968 computer, Raytheon. Yep, and it reads floppy disk. Well, not so floppy. What these discs are, I'm going to say that's about 16-bit. There's 8-bit on the bottom, 8-bit on the top. Kind of a little joke there, right, Raytheon? So you got these cams on the top, and what this is telling the machine to do, it's telling the machine on the top, it tells the needle, okay, how to traverse, to make a pattern. This needle can go back and forth while it's sewing, okay? And then what the bottom here does is it tells the machine to go forward or reverse. So you got this double cam running on this computer. It fits right in here, okay? And moves these mechanisms. You can see it's attached here, it's attached elsewhere. starts telling that foot what to do and what the needle to do as you sew. Okay? And there's 36 of these. So this machine not only could do the built-in 4 stitches, it's got 36 more stitches it can do. And this one does a goose. Yeah, it can sew a line of geese. Not a line of gooses, but a line of geese. Yep, little hay ducks right there. This machine can sew them. So anyway, we continue past the computer. The shaft continues, all right, supported by its 2 bearings. Not 3 bearings, not 4 bearings, but only 2 bearings. This bearing is actually your axial bearing. Okay, it's locked in here, so it keeps the shaft from moving in this direction. And this bearing over here is your floater. This one is allowed to float very little. It's probably only a few thousandths of an inch, but it takes up the tolerance. So you got everything locked in solid over here, and it's floating over there. But anyhow, it continues through here, okay, and it goes into another crankshaft. What you see right there is the counterweight of the crankshaft, that gold piece. See, it's moving around, okay, and now it's moving. This is your needle drive. It's driving the needle up and driving it down. What it's also doing is it has this little bell crank here that the thread goes through, and after the needle goes down, it goes through the fabric, and then what this little guy does right here is it pulls the stitch tight, okay, that little lever. So all that's going on there. So you got it right there in the top of the machine. You got a crankshaft, a camshaft, a worm drive, another bearing support, and another crankshaft, okay, and some bell cranks. Let's take a look at the bottom of the machine now. Let's remember, so everything that goes on in the bottom of the machine is taken care of here by this crankshaft and this camshaft. Let's take a look. Just check on focus there. Can you see that good? Oh yeah, that's perfect. All right, shed a little light. So again, we have the motor there. Congratulations to Hannah, who guessed right that she saw this Sears Kenmore, and let's give a shout out to that. So here's your belt. Driven from your motor, goes up to the flywheel, turns the crankshaft, comes back down here. This is your crankshaft connection. You can see right here. Okay, see as I turn the crankshaft up top? Alright, so it's taking that rotary motion up top and it's making it an up and down motion. Again, that up and down motion is transferred along this shaft. This shaft doesn't spin, it just goes back and forth, back and forth. Now that shaft has another cam put on it. This cam has a cam follower, another fork. Remember we saw a fork on the top following a cam back and forth like this? Same thing. However, because it's in a different plane, different motion, what this cam is doing, it's moving that dog foot forward and aft, every rotation, okay, forward and aft. So you take this, now the top cam that was moving it up and down is coming down right here. See right here? You watch, it's going to move. And what that's doing, that's just moving the foot up. You see, it doesn't move very much. It doesn't have it. It brings the foot up, and I guess it's about 1.5 millimeters and down, up, down, up, down, up, down. This one, back, forth. So you combine that motion, and what's the foot doing? It's going in a circle like this, moving the fabric along as the needle's going in and out, okay? Moving the fabric, and the needle goes up and down with a crankshaft down here. That shaft continues, okay, into a gearbox right here. This is a little bevel mesh. I showed you a picture on LinkedIn. I'll toss it into the video as well. Okay, and what this does, it takes that final back and forth motion and it sends it up to the shuttlecock. On a sewing machine that's known as a bobbin. Okay, this is your bobbin. Okay, any of you that sew understand what a bobbin does. A bobbin is your second thread. You need 2 threads to sew a stitch. There's a top thread, okay, and there's a bottom thread. It's just like a weaving machine. If you look up on the internet, look up weaving machines. That's kind of why I call this a shuttlecock, because that's what it is in a sewing machine. In a weaving machine, you have a bunch of threads, okay, and they're all what the weaving machine does, or the loom does, is it pulls the threads out of plane. So one's up, one's down, one's up, one's down. And then what the shuttlecock does, it takes another thread and it shoots it through all those threads, okay? And then the shuttlecock's over here, and then the weaver switches it the other direction. Then we shoot the thread through the other way. That's weaving, okay? And that goes up and down, and the shuttlecock goes back and forth, and you make fabric. That's how fabric's made, all right? In a sewing machine, you're basically making one line, or one weave, I guess. I might not be using the right terminology, of fabric. So what the needle does, the needle comes down. Okay, it's got a thread to it. It's actually making a loop. It's bringing a loop down. Then what the bobbin does, it sends the thread through the loop, comes over here. Then the needle picks up. Now the thread comes back. The needle goes down, goes through, comes up, comes back. There's your stitch. You're up and down. That's how the stitching happens in a sewing machine. And that's the mechanics of it. All by one motor, okay, making all these things happen. You're making this shaft go back and forth, this shaft go back and forth, this go up and down, this go up and down, this go back and forth, which makes that go back and forth. All that motion to make two threads go down, through, and up. Back, down, through, and up. All that for that. And it does it quite efficiently. And like we said, this old 1968 machine does it really, really well. I was happy to bring it back to life. And with that, I'm going to thread it up and I'm going to show you it sewing. Bob will be happy to see that because that wasn't the case when we first got it, and now it is. All right. Alright, so finally, after all that cams and cranks and cams and anyway, what all that was about was to basically do this. And all that stuff has to be timed properly. Do that. Okay, what I discovered, actually when I tried to do this part of the video earlier, I tested it earlier, but I didn't get close enough, and I also realized I was having difficulty threading the machine. And what that was about was that bevel mesh I told you about. I was one tooth off when I reassembled it, and that was making it difficult to thread the machine. So I went back in and I moved it one tooth, and everything's perfect now. Quite a machine. Thanks guys. Bye.